right, hey, today we are talking about igneous rocks. And igneous rocks really are just rocks that are made from lava or magma. So we're talking about super hot molten material that cools and solidifies and it produces a rock. And with igneous rocks, there's two categories of igneous rocks, either intrusive igneous rocks or extrusive. And it's kind of easy to tell those two apart, like to figure out the difference there, because intrusive form inside the earth. And extrusive, that EX, like an exit sign, means they form on the surface of earth. If we take a closer look at the intrusive igneous rocks, these rocks are formed from magma. Magma is the term we use for this molten material when it's inside the earth. And magma, deep inside the earth, has many, many layers of rocks surrounding it. Those rock layers act like insulation, trapping in all of the heat. And because all of that heat has a hard time escaping, the magma takes a really, really long time to solidify. And that whole long period of slow cooling allows minerals to form, and then those mineral crystals to migrate and collect together to produce big mineral crystals. So intrusive igneous rocks, they have a slow rate of cooling, and they'll have large crystals. And the difference between like a large and a small crystal are that large crystals are ones that you can look at the rock just with your naked eye, and you can identify minerals like quartz or feldspar or magnetite within a chunk of, let's say, granite. Extrusive igneous rocks are formed from lava. Okay, lava is the term we use when that magma that's inside the earth comes out to the surface. Then we call it lava. And since lava does not have all of those layers of rock surrounding it, there's no insulation, meaning the lava loses its heat very rapidly. So it produces a fast rate of cooling, and because it cools so rapidly, it still forms mineral crystals, okay? But those mineral crystals don't have time to move together and collect into large minerals. So extrusive igneous rocks have small crystals. So they have quartz and feldspar and magnetite within that rock. They're just too small for you to identify them with your eye. You'd need a microscope or something like that to identify those minerals. When it comes to naming an igneous rock, there's really two main factors that are involved to help us come up with that igneous rock name. It's going to be the texture and the composition group. Okay, the texture with igneous rocks, we're not really talking about the way something like feels, like the texture of it. Texture with igneous rocks just simply means crystal size. And there's 4 different igneous rock textures. The first texture is coarse-grained, and coarse-grained igneous rocks are ones that have large crystals. So again, that means a slow rate of cooling and minerals that you can identify with your naked eye. The second type of igneous texture is fine-grained texture. And these are rocks that form from lava, extrusive, and the minerals are just too small to see. So it has a fast rate of cooling and small crystals. The last 2 textures, they're not really very common, okay? The third texture is glassy, and a glassy texture doesn't really describe the way it might look or feel. Again, igneous texture is all about crystal size. So a glassy igneous texture just means the rock is cooled extremely fast, like when lava pours into water. That's the fastest way to cool lava down. And what happens with a glassy texture is that the rock, the magma, cools off so fast that even the ions in the lava, they don't have time to produce bonds to make mineral crystals. So it cools off so rapidly that there's not even really mineral crystals present. And just to prove it, both obsidian and pumice are both a glassy texture. Although they look and feel completely different, they both form when lava flows into water. Obsidian is a very low gas lava, okay, kind of like water would be. But pumice forms from a very high gas lava, like a soda. So when you shake up a soda and open it, all of that gas escapes. And that's kind of the type of lava, almost like a foamy, frothy lava that forms pumice. The last igneous texture that's not very common is porphyritic. And porphyritic textures just mean that one rock has both small crystals and large crystals. And the way this happens, we have 2 different rates of cooling. If you think about it for a second, you might be able to come up with the answer for this. How do we get a rock that has two different rates of cooling? The answer is eruptions. So you start off with magma inside the earth cooling very slowly, and it's growing large crystals. Those large crystals are surrounded by magma still, and then we have a volcanic eruption. So now that magma chamber that's partially cooled off, it has some large crystals. The crystals and the magma get erupted to the surface to be lava, where the rate of cooling is now much faster. So the remaining molten material cools very rapidly around these large crystals. So you have one rock that has two distinct rates of cooling, large crystals and small crystals. The second important part of naming an igneous rock is composition group. And that word composition, you should know that one. It's really just what is the rock made out of. And here again we have 4 different composition groups. 3 of them are common in the crust, and 1 comes from the layer below the crust. And when we think about composition groups, we can really just think about the color of the rock. And there's a scale from very light colored to very dark colored, and there's somewhere in between. If we start on the very light colored side of our spectrum of composition groups, we have the granitic or felsic composition, which is a rock that's mainly made out of light colored minerals like feldspar and quartz. Our continents have a felsic composition. The dark side of the spectrum would be basaltic or mafic, and these rocks have very few light colored minerals in them. The ocean floor has a mafic or basaltic composition. And right in the middle, we have the intermediate or the andesitic composition group. So this one is more or less 50-50 light and dark, although technically you can look at your notes and see that it's closer to 25 to 35% the dark colored minerals, okay? So not a whole lot of those dark colored minerals, it's mainly light colored minerals, but this is more like that salt and pepper type rock, a Dalmatian dog, that has more dark minerals than felsic composition rocks. And the fourth composition group that doesn't come from the crust, but it comes from the layer below the crust called the mantle, is the ultramafic composition group. And this composition group just has a really high concentration of metals and the minerals that come from the mantle. Okay, so they would have a much higher amount of things like iron and aluminum and magnesium and some of those metals. The last thing we see in our notes is a little table where you can see that there is the texture and the composition. And when you match those two things up, a certain texture with a certain composition, you end up with a rock name. Okay, that's the way we name these igneous rocks, their texture and their composition. So you can have an igneous rock that has the exact same composition. They're both felsic, they're both light colored. But because those two rocks have a different texture, one is coarse grain and one is fine grain, you would get 2 different rock names. Coarse grain and felsic is granite, where we have fine grain and felsic is rhyolite. This list of rocks are ones that you should know for the test, and you should be able to understand and name the texture and the composition that represents each of these rocks. All right, make sure you rewatch this video, you fill in your notes. This is something we're going to talk a lot about in the future. And if you have any questions, please make sure to ask. Thanks.